welcome back. On today's agenda, we're going to go ahead and we're going to review angle relationships. So that just means that we're going to be doing some practice problems from based off of the notes from last week and the week prior. So we can go ahead and practice our angle relationships. At the very end of this lesson, there is a Google form to check for your understanding. By the end of class today, you should be able to solve for missing values and describe angle relationships. That's your goal. So going ahead and looking at this first problem, it says solve for the x value that would make m parallel to n. So we want it so that this line m is parallel to n. So the first thing that you want to do is looking at your two angles. Are those two angles inside or outside of lines m and n? So they're inside. Remember the word to describe inside when we're talking about angle relationships, we're going to use the word interior. And then we're going to look at this problem and see these two angles. They're on the opposite sides of the transversal, so that means that they're alternate. Remember, when they're diagonal from each other, we use the word alternate. So these angles are alternate interior angles. And then what's the rule when it comes to two lines being parallel? How do you know if they're parallel based off of alternate interior angles? Well, we should see that these two angles are congruent so that we can say the lines m and n are parallel. So that means 3x has to be equal to 2x plus 20. So I'm going to go ahead so I can solve for x. I'm going to set those two equations equal to each other, and then from there I'm just going to solve for x. So I want to get my variable on one side and then my constant on the other so that I can solve for x. So what I'm going to do here is I'm going to go ahead and I'm going to subtract 2x from both sides. So 20 equals x. And then I'm going to go ahead, even though I'm done technically with the problem, because it just said solve for x, I'm just going to go ahead and do a quick check of my work by substituting in 20 back into that original equation that I created and seeing if it's true. So 2 times 20, because wherever I've seen x, now I'm just replacing it with the value of 20. 2 times 20 plus 20 is equal to 3 times 20. 2 times 20 is 40 plus 20 is equal to 3 times 20 is 60. 40 plus 20 is 60. 60 is equal to 60. That's true. Okay, so now we're going to go ahead and look at this problem. What is the relationship between angle 2 and angle 7? So again, the first thing that I'm going to look at is I'm going to see 2 and 7. In terms of line J and K, are these two angles inside or outside those two lines? And in this case, they're both inside. So that means right away it should kind of make me recall the word interior since I'm looking on the inside of those lines. And then I have this transversal line T, and 2 and 7 are on opposite sides of that angle T because 2 is above it, 7 is below it. So they're diagonal from each other, and that means I should be thinking of the vocab term alternate. So these two angles are alternate interior angles. So 2 and 7 are alternate interior. And then we want to go ahead and again solve for the value of x that would make m and n parallel to one another. So I'm going to look at line m and line n, and if I look at these two angles that are given, do they lie again inside or outside of those parallel, or sorry, not parallel yet, we don't know. Do they lie inside or outside of those two lines? They lie outside, so you should be thinking of the term exterior. And then again, if we use this as our transversal line, these two angles are on opposite sides of the transversal, and again, they're diagonal from one another. So that should spark the term for you, alternate. So these two angles are alternate exterior angles. And then again, when they're alternate exterior, what is the rule in order to see if they're parallel? Alternate interior angles are congruent when the lines are parallel. So that means just like 2 examples ago, we're going to go ahead and we're going to set these two equations equal to one another. And then again, I want to get my variable on one side of my equation and then my constants on the other. So I'm going to go ahead and I'm going to add x to both sides. 180 is equal to 2x. My last step, I want to isolate x, so I'm going to divide by 2, and I get 90. And then I'm going to go ahead and substitute that 90 back into my equation, just to check and verify. 180 minus x, and remember x is 90, so I replace it with 90 is equal to, is equal to x, and again, I just replaced x with 90. So 180 minus 90 equals 90, 180 minus 90 equals 90, 90 is equal to 90, that is true. So